All right, 8.6 is the last section we're going to cover here in Chapter 8. And this one, the title of it will tell you what we're doing. As we do in most chapters here, we are eventually getting to the concept of solving equations, which we've really done in every chapter we've done so far, but now we're doing it with rational equations. So rational functions are what we've been dealing with for all of Chapter 8, and now we're getting to solving equations. And in a way, I don't want to say that this is easier than what we've been doing, but when it comes to solving equations, most of you guys at this level are at least pretty familiar with some general steps for how to do it, but more to the point, you know when you're done. You're done solving an equation when you end up with your variable, usually x, is equal to some constant like 8, and when you get to that spot, when the x is all by itself, that's when you box up your answer and you're done. And another nice thing about solving equations is you can always check your answer by plugging that solution back into the original equation and making sure that you end up with something that is true. So there's some benefits to solving equations that in some ways make it a little bit easier than the simplifying expressions we were doing in the last few sections. So I've tried to boil this down as much as I can to one big idea right here, one big key concept. And here's what we're going to do in this section. We are going to multiply each term in the entire equation by the LCD, the lowest common denominator. And when we do that, that is going to completely eliminate all of the denominators. And if you don't have any denominators, that means you don't have any fractions. So at that point, once we've eliminated all of those fractions, you're going to be left with an equation that's going to be much, much, much easier to solve than what you started with. And I think you guys are going to know what to do when you get to that spot. So let's dive into our first example here, guys. 4 over x plus 5 over 2 is equal to a negative 11 over x. And our job is to solve this equation, meaning find the value or values of x that make this statement true. Now, I don't think this is one you can just look at and say, oh, obviously the answer is x equals 7. This is a fairly tricky problem in that regard. And so we're dealing with 3 fractions right here. 2 added together on the left equals 1 on the right. So how are we going to handle this? Let's go back to our key concept. We're going to need to find the LCD first and then worry about multiplying it through. Now, I would normally tell you guys to factor as much as you could right here in order to find your LCD, but everything in this problem is a monomial. The 4, the x, the 5, the 2, the negative 11, and the x. So there's no factoring that you can do here with monomials. So that means we're ready to go ahead and start building the lowest common denominator. Now the way we're going to do this is identical to what we just got talking about in 8.5 when we were adding and subtracting. You start off with the first denominator right here and you write down every factor that was in the first denominator. That's an x, and that's it. Then you move on to the second denominator here, which is 2. And every factor of the second denominator that you don't already have here, you need to include. We don't already have a 2, so I'm going to put 1 in front of the x. Then we'll go to the third denominator here, and every factor from the third denominator that you don't already have here, you need to include. Well, the third denominator here is just an x. We already have an x right here, so there's no need to write it again. That is your lowest common denominator, everybody, 2x. And what are we going to do with that? We're going to, let me go back to the key concept here, we're going to take that LCD and we're going to multiply it by each term in the entire equation. So 2x is going to get multiplied right here by the first fraction. Now, it's important, guys, for you to understand this is different from what we did in 8.5. In 8.5, don't write this down, we would have multiplied by 2x over 2x and multiplied both the numerator and the denominator by that same amount. But that is not what we're doing here in 8.6. We can multiply by 2x, which is going to change the value of a term on the left side because of this equal sign right here. You can do whatever you want, really, to the left-hand side of an equation as long as you do it to the right as well. So I'm going to multiply the second term here by a 2x, and here's the kicker now, we need to do it on the right side as well. All 3 terms in the original blue equation get multiplied by 2x. You couldn't do this in an expression, everybody. You can only do it in an equation. Now, it's important that everybody understands these red 2x's, those are all numerators. Now, you might say, wait a minute, there's no fraction. Well, very easily, we could just put that over a 1, and there you go. So the important thing is that the 2x gets multiplied by the 4, and then the x in the denominator really gets multiplied by the 1 there. So I want everybody to understand that that 2x really only goes right here. It does not go, nope, it does not go right there to the x. But I'm kind of getting ahead of myself. Something cool happens right here, and I want everybody to see it. So what's that going to be? We're multiplying 2x times 4 divided by x. Well, let's go back to 8.4. And when you're looking at one expression like this, when you're multiplying, identical factors in the numerator and the denominator cancel each other out. This is an x on the top, and it cancels with this x here on the bottom, leaving you then with just 2 times 4, which is going to get you an 8 now for all that's left from that first term. That's pretty slick. Then the plus sign is going to come right down. And what cancels now? The 2 on the top and the 2 on the bottom in the second term cancel. That leaves us with an x times 5, which is 5x. And that equals, okay, now over here on the right, the x on the top and the x on the bottom cancel each other out. We've got a negative 11 times 2. That's a negative 22. So, going back to the key concept, we have multiplied each term in the equation, there were 3 of them, by your LCD, and that has, luckily here, eliminated all of the denominators. We have no fractions left. So now, what I was hoping you guys would recognize is that the equation we are left with right here is a linear equation. And this is the kind of equation you've been solving since about 7th grade. So what are we doing here, guys? We're going to subtract that 8 from both sides of the equation here. Okay, and we're going to get 5x is equal to negative 22 minus 8 is a negative 30, and then we'll just divide both sides by 5 here, and this should be our solution now. X is equal to negative 6. Now, I'll go back and say the 2 things that students usually like about solving equations as opposed to simplifying expressions. Number 1, we know when we're done. When you get it down to variable equals constant, that's usually your answer. The second nice thing is you can check these answers by taking this value for x and plugging it back into the original statement here in blue that I'm kind of putting a purple box around right now. And when we plug in negative 6, here for x and here for x, we should end up with a true statement, the same value on both sides of the equation. So we're going to grab our calculators now. Mine's going to look a little bit different than yours, but it'll work fine. And we're going to plug in just the left-hand side of this for now. 4 over x, and we believe that x is negative 6. So 4 over negative 6 plus 5 over 2. All right, here we go, guys. So 4 over a negative 6, we said, gotcha, and then plus another fraction, and we had 5, that's not what I wanted to hit there, sorry, wrong button. There we go, 5 over 2. So that's the entire left side. I'll go ahead and hit enter now, and I got a value of 11 over 6. That doesn't mean anything to me, but now I want to check the right side, which was negative 11 over our x value of negative 6, and maybe you see this already. So let's try that as a fraction, negative 11 over negative 6. And of course, we get the exact same answer for both the left side and the right side. They both have the same value of 11 over 6, and that tells us, everybody, we've done this problem correctly, and this is the right answer. We know it beyond a shadow of a doubt because when we plugged the negative 6 back into the original equation, we got a true statement of, was it positive? Yeah, it was 11 over 6 is equal to 11 over 6, and that's why we can put a check right there because we verified this answer and we know that we got it right. All right, guys, so that is how you solve rational equations in a nutshell. Now, that was a relatively simple example because all of the numerators and denominators that I originally gave you in blue were monomials. So the plot's going to thicken a little bit when we get to a problem like this, although this one really isn't that bad either. Now, I've thrown some binomials into the mix. We have 5x over x minus 2, there's a binomial, is equal to 7 over, plus 10 over x minus 2, there's another binomial. So just to be aware of that. The first thing we would always try to do is factor, but nothing here factors. X minus 2 is a prime binomial, so there's nothing we can do there. So it's time then to start building the LCD, the lowest common denominator. So what do we do first? We take the entire first denominator, x minus 2, and we write it down without thinking too hard. Then we go to the next term and we take any factor from its denominator that's not already here and we write it in. Well, you're going to be tempted to say that 7 doesn't have a denominator. Technically it does, and it's 1. So you could put a 1 out in front of this x minus 2, but multiplying by 1 doesn't really accomplish anything at all. So even though I'd probably quibble with you at a semantic level, I think you're okay saying that this term doesn't have a denominator, and so we don't really have to worry about it. Then as we move on to the third term, its denominator is x minus 2, and we already have x minus 2 there, so there's no need to write it again. That's it, guys. That is your lowest common denominator. So what do we do with that? We're going to take that LCD and multiply it by all three terms in this equation. There's an x minus 2. It's probably a good idea to put that in parentheses. That goes right here. The same thing happens with the 7 times an x minus 2, and then also with this last term right here. All right, and it looks like that. Now, what should happen now is that all of your denominators should cancel with something that you're multiplying it by on the top. Okay, so what's that going to look like? In the first term, the x minus 2 on the top and the x minus 2 on the bottom cancel each other out. Nothing cancels in the second term because it didn't have a denominator. But in the third term, right over here, again, x minus 2 on top, x minus 2 on bottom. So what does that leave us with? This whole first term just becomes 5x. There's nothing left to multiply it by. Equals, here we have to do just a little bit of work. We're going to distribute the 7 into that binomial and get a 7x minus 14. And then at the end, the x minus 2's cancel. We just end up with a plus 10. Okay, so let's do two things at once, guys. I'm going to subtract a 7x from each side. The 5x minus 7x is going to be a negative 2x equals, now those two terms cancel, and let's combine the negative 14 plus 10 to get a negative 4 there. Then we're going to divide both sides here by negative 2, and we're going to end up with x is equal to positive 2, which looks like the one and only answer that we came up with. The interesting thing about this problem, though, guys, is what happens when you try to take that 2 and plug it back into the original equation here in blue. So let's just pay attention to this term right here and think about what happens when x is 2. The 5 times 2 on the top is going to get you a 10. But on the bottom, 2 minus 2 gets you 0. We actually just ended up now, guys, with an undefined quantity for our left-hand side. And I think you can see the same thing would happen right over here if we put that positive 2 in for x. Now, anything divided by 0 is undefined. So you're going to end up with a statement right here that says undefined is equal to undefined. And you're going to be tempted to say that's right because those two things are equal to each other. That is not the case, though, everybody. Two numerical quantities that are undefined don't exist. And the word equal means having the same value. These two terms don't have a value, or these two sides, expressions, don't have a value. So we end up now having to throw out the one and only solution that we came up with. And the word for that, if you were wondering what this was right over here, guys, the word for that is what we call an extraneous solution there. Sorry, that looks a little funny. And extraneous really just means extra. You can just kind of focus on that right there. Extraneous then means that we got a solution algebraically, but when we actually thought about it to see if it works out, it didn't make any sense. So we have to toss it because it gives you an impossible statement. Undefined equals undefined. So if we only got one solution, and it turns out it was extraneous and we have to toss it, then that means that the real answer to this problem right here is that there is no solution to this equation. There is no real number that you can put in here for x that will give you the same value on the left and right sides of this equation. So the answer here ends up being no solution because we had to toss out the only one that looked like it was going to work. So that can happen from time to time. And that's why it's really important then, everybody, when you're working on your homework for 8-6, that once you come up with that value for x, you don't just pat yourself on the back and get out of Dodge and move on to the next problem. You have to, in this section right here, go back and test those solutions and make sure they actually work and they're not extraneous. All right, I got 2 more problems for you guys, but I think you're getting the gist of how this is working so far. Okay, so here's what's happening here, guys. We've got 4x plus 1 over x plus 1 is equal to 12 over x squared minus 1, and then plus 3. Now, the one kind of significant difference right here in this problem compared to the last 2 is I've now given you one denominator that can be factored. So as a good rule, just to keep in mind for everything we do in Chapter 8, if you can factor any denominators, you should do that. Now that, I believe, is the only thing that factors here. So we're going to end up with a 4x plus 1 over x plus 1. I can't change that first term at all. Nothing factors. And that equals, here we go. Now, the 12 you can't do anything with, but that denominator right there is a difference of squares. And I really hope by this point we're good at dealing with that. That becomes an x plus 1 times an x minus 1. Okay, there we go. And then a plus 3 at the end of all that. So now that we've factored every denominator that we can, let's start thinking about our LCD. Just like always, we begin with the entire first denominator, which is x plus 1, and we write that down here. And I'm going to put parentheses around that. Then we move on to the second denominator, and we now write down every factor from the second denominator that wasn't already here. Do we already have an x plus 1? Yes, we do, so there's no need to write it again. Do we already have an x minus 1? No, we don't, so we need to include a factor of x minus 1 at the end of that. And there really is no denominator from the third term to worry about, just a 1, so this is our LCD, everybody, x plus 1 over x minus 1. And if we go back to our key concept from right at the beginning of the notes, we are now going to multiply every term in the equation by the LCD. So that x plus 1, x minus 1, if I left myself enough room, I'm going to have to cram that in here, guys. So this is going to be x plus 1, x minus 1. And notice, guys, I'm kind of drawing it right in the middle of that fraction there, or writing it up on top would be fine too, because it's actually part of the numerator. What you don't do is put it down here in the denominator. That's the one spot you can't put it. So I kind of like it right in the middle there, like that. On the second term, I'm going to go ahead and put it in the numerator, which is the other thing that I said was okay. X plus 1, x minus 1. And then here it just needs to get multiplied on the same level as the 3, x plus 1, x minus 1. So what happens now? Looking at the first term way out here to the left, we have an x plus 1 on top and an x plus 1 on bottom. They cancel each other out. Looking at the second term right here, this is actually really good news, you guys. X plus 1 on the top, x plus 1 on the bottom cancel out. I just realized I wrote something wrong here. Sorry. That should have been an x minus 1. Why didn't anybody yell at me about that? Oh, okay, x minus 1. There you go, which makes my next step possible. X minus 1 on top, x minus 1 on bottom. Those are gone. In the third term, there was no denominator, so nothing cancels. Okay, so now it's time to multiply out everything that's left. And what's left from the first term are these two binomials being multiplied together, x minus 1 times 4x plus 1. And how do we multiply two binomials? FOIL. First, outer, inner, last. So the first product, x times 4x, is going to be a 4x squared. Now the outer product, x times 1 is 1x. The inner product right here, negative 1 times x, is a negative 4x. So mentally, let's combine a positive 1x and a negative 4x. That'll get us a negative 3x. And then our last product, negative 1 times positive 1, is negative 1. Equals, now what happens here? Everything canceled right here in the second term right here, except for the 12. So the 12 comes straight down. This plus sign then comes down next, and nothing canceled right here, so we have to multiply 3 times x plus 1 times x minus 1. But I want to remind you, the x plus 1, x minus 1, which I had right here, is the factored version of x squared minus 1. So multiplying these two back out would get us right back where we started at x squared minus 1. And now I'm just going to distribute the 3 in there to get a, let's see, a plus 3x squared and then a minus 3 at the end of all that. Okay, so I was able to kind of skip a step right there and maybe get done just a little bit quicker. Okay, so here's where we are right now. Now the good news is, like we expected from the last two problems, all of your denominators have canceled out right here. You no longer have a rational equation. But in the last two problems, the equation that you ended up with at this line right here was linear. Let's take a look. That happened right, oh, I had to scroll a little bit. Okay, that happened right here. Linear equation there, and it happened right here, linear equation as well. But in this problem, you have these x squared terms here, and I don't think they're going to cancel each other out. That means that this is not a linear equation, it is a quadratic equation. And we've been solving quadratics in one way, shape, or form or another for the, let's see, all the way since chapter 4. So it's been quite a while, everybody. So let's see if we remember how to do it. Step number 1 to solving a quadratic, you want to get everything on one side. So I'm going to subtract, let's see, I got a 4x squared on the left, 3x squared on the right. You always want to move the smaller to the bigger. So we're going to move that 3x squared by subtracting it from both sides. And then what do we have here, guys? Positive 12, negative 3. That makes a positive 9. And how do we move positive 9? We subtract 9 from both sides. So we're doing the same thing on both sides. That term will cancel with that. And then 12 minus 3 is 9, which cancels with that minus 9. So where are we then? 4x squared minus 3x squared is a 1x squared. There's nothing to combine with negative 3x, so it comes straight down. And then negative 1 minus 9 is a negative 10, all of which is going to equal 0. Okay, so here's where we are now, and this is a spot we should be relatively comfortable. We have a quadratic set equal to 0. We could solve this with 3 methods, either factoring, completing the square, which I like but nobody else does, or quadratic formula. Factoring's the thing to try first, so let's see if we can have any luck here. There's no GCF to pull out. How would we split up the x squared? Into x times x. Now, let's read our signs. The fact that this sign here, C, is negative, tells me that one of these signs is a plus and one is a minus. And I need two constants now, two numbers that multiply to negative 10 and add up to negative 3. Hopefully you don't have to think too hard about that. That's going to be a positive 2 and a negative 5. And you're welcome to do FOIL right here, but I think this is going to work out. That's a negative 5x and a plus 2x. Those combine to the negative 3x that we needed. The first two product is going to be x squared. The last product is negative 10. Yeah, we're in the right spot here, guys. So here's where we are. And now we use the zero product property. Most of you do this in your head. You take each factor, like x plus 2, you set it equal to 0, and you solve. Minus 2, and you end up with x equals negative 2. As I said, a lot of you guys are doing that mentally these days and just going from the x plus 2 right to the solution. Good for you. Keep doing that. You're all set. Same thing right here. We set x minus 5 equal to 0, and we add 5 on both sides here, and we're going to get x equals 5. Technically, when you get two solutions, you really should write the word or in between, and we should box those up, but we definitely should check those to make sure that they both work. Now, I'm going to give you guys kind of the condensed version of how to check your answer right here. If we go back and we look at the original problem, ask yourself this question. Really, a 0 in the denominator is what you have to watch out for. And what value of x, there we go, what value of x would make this denominator equal 0? The answer to that is negative 1. Negative 1 plus 1 would be 0. So if I got a negative 1 for one of my two solutions, I'd have to throw that one out. But that didn't happen right here, so I think we're okay. Likewise, let's take a look at this denominator. Would either negative 2 or 5 make this denominator become 0? I don't think so. Negative 2 squared is 4. 4 minus 1 is 3. That's okay to have for a denominator. If we put in a 5, 5 squared is 25. 25 minus 1 is 24. That denominator is okay as well. And just to prove to you guys that this is going to work out, I'm going to go to my calculator and I'm going to pick one of these. I'm going to pick x equals 5. And I'm going to go ahead and plug it in now to the left-hand side of this equation right here. This is going to be a little bit messy. I'm going to have to bounce back a lot. So we're at, you know what, I should write this down. Okay, so 4x plus 1, and remember that x is 5. Actually, I think I can do this in my head, guys. X is 5, so 4 times 5 is 20. 20 plus 1 is 21, over 5 plus 1 is a 6 down there on the bottom. That is supposed to equal, let's take a look, we have a 12 over, and our denominator there is x squared minus 1. 5 squared is 25, minus 1 is 24, and then a plus 3. So I'm going to put that, actually I don't need to put that into my calculator, I can just divide out the 3 from the top and bottom and get a 7 over 2. How about that right side? 12 over 24 plus 3. Let's try that. So 12 over 24, get out of that fraction, and plus 3, and we end up with 7 over 2 on the right as well. So the fact that we ended up with a true statement tells me that x equals 5 is a valid solution. I'm going to ask you guys to trust me here. The same thing would happen with x is equal to negative 2. So that's a more complicated example than the first two that we did. Here's the last one I have for you right here, and I don't really know that this one is harder than what we did before, but we'll go ahead and we'll walk through this one. Okay, as we said earlier, guys, the first thing you want to do anytime you can is do any factoring in your denominators. And it looks like we have a denominator on the left here, that can be factored. So it's going to be 2 over, and x squared minus x, it's not much, but you pull out the x, and that leaves you with an x minus 1 left behind, is equal to 1 over and an x minus 1 there. That's all the factoring that you can do. So now, time to build the LCD. You start with the entire first denominator, in factored form preferably, so it's x multiplied by x minus 1. Whatever was written right here, I was automatically going to put it right there. Then you go to the second denominator here, and you put whatever factor you don't already have here, you tack on to the end. Well, the only factor here is x minus 1, and we already have an x minus 1. So we're done, guys. That is the LCD. And what do we do with that? If we go back to the key concept from the first slide, we multiply every term in the equation by that LCD. Now, there's only 2 terms in this equation, unlike the other 3 problems that had 3. So here we go. We're going to multiply by x times the quantity x minus 1. That gets multiplied here, and the same thing happens right here. X times x minus 1. And what should happen now is that everything that was in the original denominator there should cancel out. Does that happen here? I think so. X on the top, x on the bottom, gone. X minus 1 on the top, x minus 1 on the bottom, gone. The entire left side just becomes 2. And on the right side, x minus 1 on top, x minus 1 on bottom, gone, and we just end up with 1 times x, which is x. Boy, and I didn't really intend for that to happen. We're done. We've solved for x already. X is equal to 2. Now let's check that real quick and find out if it works. So going back to the original blue statement right here, let's take a look. My first numerator there is 2. My denominator is 2 squared minus 2. Well, 2 squared is 4. 4 minus 2 is 2. There you go. And we end up with a 2 over 2. Equals, how about the right side? The top right side right there is just 1. And down on the bottom, if x is 2, 2 minus 1 is 1. Well, 2 over 2 is equal to 1. 1 over 1 is equal to 1. And sure enough, that's a true statement. So I have verified this answer here, and it looks like we got the solution here of x equals 2. Guys, that's everything I have for you here in section 8.6. I think doing more problems is probably just going to slow your progress down. You need to dive into these, start getting your feet wet there, and working on some of these problems yourself. So just try to remember the big concepts that we talked about in this section right here. You're going to find the LCD, you're going to multiply through, eliminate all the denominators, and then solve the equation that's left over, which hopefully isn't going to be that bad. All right, good luck on section 8.6 homework, everybody, and let me know when you have some questions.